Well, we have another question here, question 4. The question says that below are the graphs of f of x and the straight line G. A and B are the x-intercepts of f, and E is the turning point of f. C is the y-intercept of both f and G. The x-intercept of G is D. DE is parallel to the y-axis. Now we have a question. We have questions here. Questions 4.1. As we can see, question 4.1 says write down the coordinates of E. Okay, I'm right here. Question 4.1. We're looking for the coordinates of E. Okay, E, X, Y. Now, in the question, we do have like f of x equal to, as you can see, 4, actually, I mean, x minus 4 to the power of 2 minus 9. Now, this form is the, what do you call it? They call it the turning point form of the equation of the parabola, okay? Because the turning point form is of the form like f of x equal to a open bracket x minus p close bracket to the power of 2 plus q, where p and q here stand for the coordinate of the turning points. Okay, so the turning points will be at p, q. Okay, so in this situation, the coordinate of turning points E, the coordinates are positive 4 and negative 9. Okay, so E is 4, negative 9. So we have another question 9. Question, okay, let me write here. E is 4, negative 9, and then the following question is question 4.2. This one, it says calculate the coordinates of A. So the coordinate of A, the point A is this point there. So as we can notice that A is an x-intercept. So let me write here 4.2. We're looking for the coordinate of A. So x, y. I say A is an x-intercept, therefore the y value is 0. So that's going to be x 0 there, because the reason is that A is an intercept, is x-intercept. Okay, so in other words, in the equation of the parabola here, we're going to substitute y by 0. So this will be then when I write here, okay, let me first start by writing f of x, which is y, okay, equal to x minus 4 to the power of 2 minus 9. We sub in the value of y by 0, and then this will be 0 equal to x minus 4 to the power of 2 minus 9. Now, let me move. Okay, let's just move a little bit up there. We could solve this by expanding x minus 4 and then do calculation and then factorize. But I think the smarter way to calculate this is if we move the negative 9 over, that will be like 9 equal to x minus 4 to the power of 2. You know, 9 is a square number, so this can be written as 3 squared, okay? And then this is equal to x minus 4 to the power of 2. Now you notice that we have power of 2 here and power of 2 there. We can apply the law of exponent that says like a to the m equal to b to the m. You know, when the exponents are the same, this means the base in the equation like this must also be the same. So we're going to equate the bases. So this is going to be like plus minus 3. Careful, over here always use, when you have an equation, use plus minus. Plus minus 3 equal to x minus 4. Okay. In other words, is like we introduce the square root here, a square root here, a square root there. Excuse me, I put yeah, you put plus minus there, so that's gonna be and then if I move the negative 4 over, okay, this will be if I move the negative 4 over, this might be like, okay, let me just write x minus 4 equal to plus minus 3. I reverse the order. So if I move the negative 4 over, so it might be x equal to plus minus 3 plus 4. So there are two possible answers here. Either x equal to 3 plus 4, which is 7, or negative 3 plus 4, which will be 1. Now, which one is the actual value of A, the x value of A? Yes, it's easy to see that A must be the x equal to 1, but let's prove it out. I'm gonna look at the value of E, because A must be lesser. The exponent of A must be lesser than the exponent of E, because E, the exponent of E is a little bit further than the exponent of A. So if I look at here, if E is 4, A cannot be 7, you know, A is 1. A is 1. So the coordinate of A is 1, because this one is not applicable. So not applicable. So the coordinate of the x coordinate of A is 1. Therefore, so we can say therefore A is the point 1, 0. Okay. Okay, in other words, okay, the x equal to 7 here, this is the coordinate of B, because B is also the x-intercept. Okay, there are two intercepts here. A and B are both the x-intercepts. So this 7 here is the coordinate of B. Now, the following question is, as we can see, there, question 4.3. The question says that M is the reflection of C in the x-axis of symmetry of F. Write down the equation, write down the coordinates of M. All right. Before even I do M, maybe let's solve this problem in a different way. As I was saying over here, I prefer to just square root both sides in case this is complicate anybody, because the power of 2 here we cancel the square root, we cancel the power of 2. In other words, was to expand this x minus 4 to the power of 2 minus 4 here. Let me do it over here. I want to do it over here. So we have like x minus 4 to the power of 2 minus 9 equal to 0. So this will be like x minus 4 times x minus 4 minus 9 equal to 0. And then if we do x times x times negative 4, negative 4 times x, negative 4 times negative 4, this will be x squared minus 8x, I simplify, okay, plus 16 minus 9. And then we will get things like something like, okay, equal to 0. And then, 16 minus 9 is 7. So like x squared minus 8x plus 7 equal to 0. Now over here, we can also factorize. Okay, we factorize. And then, we're going to consider the constant term negative, positive 7. Okay, the factors of 7 are just 1 and 7. Now, if I need to get negative 8, the coefficient of the middle term, this is possible if it's minus 7 and minus 1, because minus 1 minus 7 makes minus 8, and then minus 1 times minus 7 makes positive 7. So over here we have like minus 1 and then minus 7, and then over here this simply means that x minus 1 is 0, or x minus 7 is 0. And this means x is 1 or x is 7. So this is how another way of solving this in order to get the x-intercept. Now, question 3, or saying question 3 here, the question says that M is the reflection of C in the axis of symmetry of F. Write down the coordinates of M. Now, okay, I prefer to move my board over here. Question 4.3. Okay, so for better insight, I prefer to reproduce the same diagram over here. We're looking for the coordinates of M. Okay, which is the reflection of C on the axis of symmetry. Now let's first represent the same diagram here. So here is the diagram. Now I can extend this. Well, I can extend this. I was saying this the line of symmetry. You know, the line of symmetry is the line that passes through the turning point. So we already have it there. So let me just write it like, try to extend it. This will be okay, this line. So yeah, that's the line of symmetry. Now the question says that M is the reflection of C on the vertical line here, because this is a vertical line. So here the point C is given. The point C was given by 0, 7. Okay. I say given because I did the calculations over here, because C is, if you look at the value C, is the y-intercept. Okay, so y-intercept is simply, you know, if you expand this as we did over here, when we expand this, we got like x squared minus 9x plus 7. Okay, so the y-intercept is just 7 here. So over here, the point, the coordinate of C is 7. Now, if we reflect C on okay, so when I look at from C here to the line of symmetry, it's 4 units. Okay, and it must be constant. We need to add another 4 units. Okay, so from over here, so it must be another 4 units. So in other words, the total of 8 units, because 4 units here from 0 to there, and then 4 units to there also, 4 units, and then here the point of symmetry will be the x coordinate must be 8, and then obviously the y coordinates will still going to be 7. So these 2 points will be symmetrical towards they're symmetrical, okay, towards this line, the line of symmetry. Yeah. So the point M is 8, 7. Okay. The following question. The following question, I'm gonna move my board like this. Question 4.4. Okay. Question 4.4 says determine the equation of G in the form y equal to mx plus c. Now I'm gonna move my board over here. Question 4.4. Oops. It's gonna be like 4.4. We're looking for the equation y in the form mx plus c. Okay, that's the general form of a straight line, and of course, because G here is a straight line. Now, to find, we're looking for this equation. Let me just highlight it. The equation of this line. Then in the equation of the straight line, m is the gradient, you know, c is the x-intercept. We can see that the actually c is the y-intercept, I mean. So we already have the y-intercept here, which is 7, and then we need to find the gradient. Now, how can we get the gradients? We can use 2 points. We have c, the points, which is the point 0, 7. Okay, it's the point 0, 7, and then we also have d here, which is the x-intercept. Okay, it's the point, the x value is 4, and then the y value must be 0. So we can use the gradients over here. The gradient will be m equal to, so I will do 0 minus 7 over 4 minus 0, and then this is equal to negative 7 over 4. Then we can write our equation will be negative 7 over 4 x plus 7. And then okay, then we have like the equation of the equation of the straight line. Okay, negative 7 over 4 plus negative 7 over 4x plus 7. Now the question 4.5 will be, let's see the next question, question 4.5. The question says that write down the equation g minus 1 in the form of y equal to. All right, let me move it over here. We have 4.5. So we're looking for g minus 1. Okay, the inverse of g. G, we did find g was, okay, the graph of g is y equal to negative 7 over 4x plus 7. Okay, now g minus 1 is when we will switch the variables x and y. So y will becomes x become y, will be equal to negative 7 over 4 y plus 7, and then we're going to make y subject of the formula. So I'll move positive 7 over, that makes x minus 7. Okay, x minus 7 equal to negative 7 over 4 y. Okay, and then if I need to get the value, it's like we have like negative 7 over 4 y equal to x minus 7. So if I need to find the value of y, this is what I can do. I will times the whole equation by the inverse of negative 7 over 4. I'll times it by negative 4 over 7. Okay, negative 4 over 7. So it's like negative 4 over 7 times negative 7 over 4 y. This is equal to negative 4 over 7 x minus 7. Oops, it's a bit let me just redo it. I meant to write, this would be like, our times here by negative 4 over 7. So we have like negative 7 over 4y equal to, and then there also has times by negative 4 over 7. Okay, whatever we do on the left, we do on the right. So times x minus 7. Now, why I choose that? Because I know the negative and negative cancel out, and then the 4 at the numerator we cancel the 4 at the denominator, and the 7 at the denominator we cancel with the 7 at the numerator there, and then I left with y equal to, and then negative 4 over 7x plus, because minus here times minus make plus, 4 over 7 times 7 is just equal to 4. Okay, because the 7s will cancel. Okay, we cancel out. Then and then g minus 1 is just y equal to negative 4 over 7x plus 4. Okay, and then the last question will be question 4.6. So I need to move my board over here to see question 4.6. Is this question over here? The question says that for which values of x will x times f of x will be lesser than or equal to 0. Okay, so now let me move it over here. Four 0.6. So we're looking for the values of x, okay, for which x times f of x will be lesser than or equal to 0. Now, so how can we do that? So this is, we have like x times f of x is given, when we expand f of x, it is given the form x squared minus, it was 8x plus 7. Let's double check. Let's see, all this is f of x. All this is just f of x, okay? Let us double check it. Let's double check it. We did work it out here when we just calculated f of x, expand it, and then we got like x squared minus 8x plus 7 equal to 0. That was f of x. So over here, we can continue. We factorize this. We factorized this. It was x minus 1 times x minus 7 equal to 0. If you factorize this, we did it earlier. If you can double check. We got this, and then this is the critical values here are 0, okay, 1, and 7. So these are the critical values, okay? The critical values. Now we can draw a number line to represent these critical values, and then see which interval x times f of x is lesser than or equal to 0. Now let's see. We need to put the values in ascending order, okay? So like 0 here, 1 over here, let's see 1 is there, and then 7 is there. So like now 0 is here, 1 is there, and then 7 there. Okay, now excuse me. If I select a value in this interval, okay, a random number, I take a number like -1, for instance. If I take a number like -1 here, or maybe I need to put it -1 over here underneath. So if I start with -1 here, -1 there, -1 there, and then let's see what should be the answer, positive or negative. So if I put -1 here and -1 there, we're like, it's gonna be this is negative, this will be a negative answer, that will also be negative. Okay, so we will have negative times negative times negative makes negative. So in this interval, okay, it's going to be negative all over. So in this interval, the solution will be negative. Now let's move on. In the interval between 0 and 1, I take a number, pick up a random number like a half, for instance. Okay, we're going to substitute a half here, a half there, and a half there, and then see. If a half is positive, so this side is positive, a half minus 1 is negative. Okay, so this side is positive. A half minus 1, maybe that's going to be, this is positive. A half minus 1 is negative, and a half minus 7 is also negative. Now here we have like positive times negative times negative. All this makes positive. Okay, So this simply means in this interval, the solution will be positive. So over here, the solution is positive. I said I have there. Over here it's positive. I said here it was a half. Now let's pick up another number here. Any number, it will work. I can take a number like 3, for instance. Underneath here, 3. If I have 3 here, 3 there, and 3 there also, we could have like this side is positive, that will be positive, and x minus 7 is negative. Now you know that positive times positive will make positive. Positive times negative will make negative. So in this interval, here the solution is negative. Okay. So over here the solution is negative. Then I can also look at the next interval. If I pick up another number like 10, it doesn't matter which one. I take 10 here and then 10 there and then 10 there. And then you notice that 10 is positive and 10 minus 1 is positive. 10 minus 7 is also positive. So positive times positive times positive, still positive. Now, our interest is where the solution is negative, because we want, they say it here, f of x times f of x is lesser than or equal to 0, which means this means a negative. Okay, so it's going to be there and also there. I meant and also over here. So our solution is x is lesser than or equal to 0, okay, or x is in between 1 and 7, so like that. So x is lesser than 0, or x is between 1 and 7 in this interval here. So this is the solution. Thank you.